We want to find the total mass of 3 turns of a wire spring along r of t with density given by rho of x, y, z. Let's first take a look at the spring in space. Here we see the graph of r of t, which would be the path of the spring in space. And we do have 3 turns in this graph. So our goal is to find the mass of this spring given the density function rho of x, y, z. We saw from our previous example, the value of a line integral will give us the mass of a wire, where the integrand function f of x, y, z is a density function, and the wire is given along curve C. So we can determine the mass of this wire by evaluating this line integral, where again f of x, y, z is a density function, and the curve C is given by r of t. So the mass of the wire is equal to the line integral along the curve C of the quantity x squared plus y squared plus z squared integrated with respect to arc length. So notice how we'll have to write the integrand function as a function of t using x of t, y of t, and z of t given by r of t, and then differential s is equal to the magnitude of r prime of t squared dt. Let's first determine f of x of t, y of t, z of t, or we can also just write f of r of t, where in our case x equals 2 cosine t, y equals 2 sine t, and z equals t. So in our case, x squared would be 4 cosine squared t, plus y squared would be 4 sine squared t, and z squared would be t squared. Let's factor out 4 from these first two terms. So we have 4 times the quantity cosine squared t plus sine squared t plus t squared. Well, we know cosine squared t plus sine squared t is equal to 1, so our function simplifies to 4 plus t squared. Now we also need to find the magnitude of r prime of t. So r prime of t would have an x component that's a derivative of 2 cosine t, which is negative 2 sine t. The y component will be the derivative of 2 sine t, which is 2 cosine t. And the z component will be the derivative of t, which is just 1. Which means the magnitude of r prime of t is equal to the square root of negative 2 sine t squared, that'd be 4 sine squared t, plus 2 cosine t squared, that'd be 4 cosine squared t, plus 1 squared. Simplifying, notice how if we factor out 4, we're going to have 4 times the quantity sine squared t plus cosine squared t plus 1, which simplifies to just the square root of 4 plus 1, or the square root of 5. So the magnitude of r prime of t is equal to the square root of 5. And now we have all the information we need in order to evaluate the line integral. The given line integral is equal to the integral of f of t, which is 4 plus t squared. The magnitude of r prime of t is equal to the square root of 5, so we have times the square root of 5 dt. And now we need to find the limits integration for t that would result in 3 turns of a wire along this curve. Going back to the graph in space, if we look down on the xy plane, we can see the xy trace is just going to be this circle with a radius of 2, where the xy trace should be given by the equations x equals 2 cosine t and y equals 2 sine t, graphed here. We know one revolution around a circle would be from 0 to 2 pi radians, and therefore for 3 turns, the interval for t would be from 0 to 6 pi radians. So 0 to 6 pi radians would be 3 turns of the wire along the curve r of t, which again we see here in space. Let's rewrite this as the square root of 5 times the integral from 0 to 6 pi of the quantity 4 plus t squared integrated with respect to t. And now let's evaluate this on the next slide. We're going to have the square root of 5 times the antiderivative of 4 plus t squared with respect to t. So we'd have 4t plus t to the third divided by 3. So we first substitute pi over 6 for t. So we'd have 4 times 6 pi plus 6 pi to the third divided by 3 minus, when t is equal to 0, notice both terms have a factor of t, so both terms would be 0. So we have the square root of 5 times the quantity 24 pi plus, this is going to be 216 pi cubed divided by 3. Well, 216 divided by 3 is equal to 72. So we have the square root of 5 times the quantity 24 pi plus 72 pi cubed. Notice how we can factor this further. The greatest common factor of 24 pi plus 72 pi cubed would be 24 pi. So let's write this as 24 square root 5 pi times the quantity 1 plus 3 pi squared. So this would be the exact value of the line integral. As a decimal approximation, this would be approximately 5,160.5098. So this does give us the mass of the wire along the curve R of t, graphed here in red, with density given by rho of x comma y comma z. I hope you found this helpful.